Assalamu alaikum, my dear students. I welcome you all. Last time we were talking about Dalton's atomic theory. We discussed certain postulates about this Dalton's atomic theory. Dalton's atomic theory, my dear students. In the last video lecture, I told you people that around 25% chemistry is based on this Dalton's atomic theory. And regarding this Dalton, I gave you the brief description regarding this Dalton, who actually this John Dalton was. He was actually English chemist. Uh, I told you people in the last video lecture that scientists were starting thinking to give appropriate explanation to the laws of chemical combination like laws of definite proportions and law of conservation of mass. And guided by the laws of chemical combination and other facts, John Dalton provided the basic theory about the nature of the matter. So he took the name atoms for the smallest particle of the matter as given by the Greek philosopher like Leucippus, like Democritus and all that. And based on the actually the laws of chemical combination, is if somebody will pose you a question that why did John Dalton proposed atomic theory? Why there was a need of atomic theory? I mean to say this is a big question. You must answer that. It was actually the laws of chemical combinations which forced actually John Dalton to propose this theory. And I told you people that around 25% chemistry is based on this atomic theory. And he proposed a model of an atom after the name John Dalton's atomic theory. We discussed certain postulates regarding this John Dalton's atomic theory. First postulate regarding this John Dalton's atomic theory was all matter is composed of very small number of particles, and we call those small indivisible particles as atoms. And he gave actually the concept of the atom. So it was actually the John Dalton in 1808. So John Dalton proposed this atomic theory in 1808. And the first postulate regarding this John Dalton's atomic theory is that every single matter you people are seeing around is made up of smallest indivisible particles, and these smallest indivisible particle John Dalton called as atoms. So, my dear students, is the first postulate. Remember this and mark my words and jot it down with me that all matter is composed of, I mean, say, made up of very small, tiny particles, and these small, tiny particles are called as atoms. And this was the first postulate regarding the John Dalton's atomic theory. And the second postulate regarding the John Dalton's atomic theory was that atoms are indivisible particles which can't be created or destroyed in a chemical reaction. What is this? Actually, this postulate of the John Dalton's atomic theory was in accordance with the law of conservation of mass. In the law of conservation of mass, my dear students, I told you people that this mass can neither be created nor destroyed, but can simply change from one form to another form. This means that atoms can't be further broken down. They are tiny, they are indivisible and indestructible. I can say indestructible ultimate particle. That's why this law is also called as law of indestructibility of matter. Means we can't destroy. I can say we can't. Neither we can break the matter nor we can create the matter. We can simply change it from one form to another form. So these were the two postulates, my dear student, we discussed in the last video lecture. Let's discuss some more postulates regarding this John Dalton's atomic theory. Let's discuss another postulates in today's video lecture. So students, let's discuss the some more postulates regarding this John Dalton's atomic theory. This John Dalton actually gave this atomic theory in 1808. I told you people that 1808, and these laws are totally based upon the laws of chemical combination like law of conservation of mass and the law of definite proportions. Uh, as far as this second postulate of John, let me recapitulate this. As far as the second postulate of John Dalton's atomic theory is concerned, these atoms are indivisible particles which can't be created nor destroyed in a chemical reaction. What does this statement mean? This means that atoms can neither be created nor destroyed in a chemical reaction. That means, for example, this law, this postulate rather, is in accordance with law of conservation of mass. So, my dear students, mark my words, the second postulate of John Dalton's atomic theory is in accordance with law of conservation of mass. So, according to the law of conservation of mass, which was given by the Anton von Lewisier in 1774, according to this law, during a chemical change, the total mass of the products is equal to the total mass of the reactants. In other words, I mean, say the law of conservation of mass means that mass can neither be created nor destroyed during a chemical change or a chemical combination, but it can simply change from one form to another form. And this law is actually also known as law of indestructibility of matter. So we discussed this thing that, for example, let me recapitulate here what I discussed with you people during that very, I can say, during that very lecture. I told you people that, for example, this is carbon. What this second postulate is telling us, this carbon, whenever reacts with oxygen, forms carbon dioxide, CO2 molecule. The moment there's a chemical reaction, atoms or individual particles which can't be created or destroyed in a chemical reaction, means whenever there's a chemical change, whenever there's a chemical reaction between the carbon and the oxygen, and these two are called as reactants. Reactants, what I'm telling you that uh, reactant side should always equal to the product side, means the mass of the reactants should equal to the mass of the products, and that is in accordance with the law of conservation of mass. So for example, this carbon is having atomic number of 6. That means it is having mass number of 12. Mass number is equal to number of neutrons plus number of protons. This number of neutrons, carbon is having 6 neutrons. Carbon is having 6 neutrons and 6 protons. I mean to say that means 12. This means that 6 protons, 6 neutrons, that's 12. 12, that's 12 plus 32. Mass of one atom, I can say one molecule is 32. Oxygen, that's 44. Whenever we measure the mass of the carbon dioxide there, the mass of the carbon dioxide comes out to be the 44 gram. That means mass of the reactant side is equal to the mass of the product side. That means the mass of the reactants is equal to the mass of the products. That means the second postulate of the Dalton's atomic theory is in accordance with the law of conservation of mass. According to the law of conservation of mass, during any chemical change, this is a chemical change means carbon is reacting with the oxygen. That means a chemical reaction is occurring between the carbon and the oxygen. That means during a chemical change, the total mass of the products is equal to the mass of the reactants is equal to mass of the product is a product, and these are the reactants. The 44 equal to 44, that means LHS equal to RHS. That means mass of the reactants is equal to the mass of the products. And that's why I told you people that based on the laws, Dalton proposed this theory, but he proposed this theory on the, I can say, based on the laws of these chemical combinations. So second postulate of the Dalton's atomic theory is in accordance with the law of conservation of mass, which states that during a chemical change, the mass of the reactants is always equal to the mass of the products. So regarding this postulate, atoms are indivisible particles which can't be created nor destroyed in a chemical reaction. So let's discuss some more postulates regarding this Dalton's atomic theory. So these were some postulates. Let's discuss some more postulates. Atoms, the third postulate of the John Dalton's atomic theory is atoms of a given element are identical in mass. They are identical in chemical properties as well. What John Dalton said in the third postulate, as far as third postulate of John Dalton's atomic theory is concerned, that means atoms of a given element. Atoms of a given element are identical in mass and chemical properties. That means atoms, all the atoms of a given element are identical in all respects, having the same mass, having the same size, having the same chemical properties. Let's take example of sodium, for example. Let's take another example, that's potassium. That means this sodium is wholly or solely made up of atoms of sodium. As far as this sodium is concerned, this sodium is composed of, I can say the sodium is made up of millions and trillions of the sodium atoms. And these atoms, what John Dalton is telling us in the third postulate, that atoms of a given element, this sodium is an element. This sodium is an element of the periodic table. What are elements? You know that, my dear students. What actually we have discussed this thing, that what actually elements are. Elements are actually the substance. Let me recapitulate here. That elements or the substances, I can say, which are made up of single type of atoms. That means uh, whenever there is a formation of an element, and whenever there is a formation of elements, or I can say made up of single type of atoms, or rather I can say only one kind of atom. So as far as the sodium is concerned, what John Dalton is telling us, that as far as the sodium is concerned, the sodium is made up of millions and trillions of the atoms, and those millions and trillions of atoms are identical. Mark my words, my dear students. They are identical with respect to mass, with respect to size, with respect to shape, my dear students. This is what John Dalton is telling us. He is telling us that atoms of a given element means this sodium. I can say, let's take the example of potassium. This potassium is made up of millions and trillions of atoms. I can say those atoms, or I can say identical with respect to mass, means mass. Every single element of the potassium is having the same mass. Mark my words, my dear student. Jot it down with me as well. That every single atom of this sodium or potassium is made up of, I can say they are having the same mass, they are having the same shape, they are having the same size as well. So that means all the atoms of a given element are identical in all respects, having the same mass, having the same size, and having the same chemical properties, means they show the same chemical behavior. For example, they are having same physical properties, they are having same chemical properties, they are having the same size, they are having the same color, they are having the same shape as well. So that's why John Dalton told us that these atoms of a given element are identical in mass and chemical properties. That means they are identical with respect to mass, with respect to size, and with respect to shape as well. So this was the third postulate of the John Dalton's atomic theory. Let's discuss one more postulate regarding this John Dalton's atomic theory. Now, the fourth postulate regarding the John Dalton's atomic theory is atoms of different elements have different masses and chemical properties. That means this postulate is actually the reverse of the postulate number third, which we discussed it, that all the atoms of a given element are identical in all respects, having the same mass, size, and the chemical properties. As far as the fourth postulate is concerned, atoms of different elements have different masses and chemical properties. It's obvious, my dear students, that atoms of different elements may have different masses, and they are having the different chemical properties. Let's discuss this. I can see, let's make more clear to you people that how the atoms of different elements have different mass and different chemical, they show different chemical behavior. Let's take an example, my dear students. Look, my dear students, the atoms of different elements have different mass and different chemical properties. Obvious, students. For example, this is carbon, this is nitrogen. These are the two different elements. Carbon and nitrogen are the two different elements. Atoms of different elements have different. This carbon is having mass of 12, and this nitrogen is having mass of 14. That means atoms of different elements have different masses. Now this carbon is having mass 12, this nitrogen is having mass of 14. That means there is a mass difference between carbon and nitrogen. That means they are the different elements, they have a different masses, and they have the different chemical behavior, means they show the different physical and the chemical properties. So the fourth postulate regarding the Dalton's atomic theory is atoms of different elements. These are the different elements, carbon and nitrogen. We can take some more examples. Atoms of different elements have different masses. They have a different masses, and they show the different chemical behavior. And they, I can say, every single atom of these two elements are identical with respect to each other, but the atoms of the carbon are not same with the atoms of nitrogen, means the atoms of nitrogen don't match with the atoms of carbon. That's why what John Dalton said, that atoms of different elements have different masses. Obvious from this example that atoms of different elements have different masses and different properties. So this was the fourth postulate of the John Dalton's atomic theory. My dear students, in the next video lecture, we are going to discuss, or we are going to study some more examples regarding more postulates rather of this John Dalton's atomic theory. Till then, keep practicing, my dear students, at your home, and stay safe, stay blessed, and thank you for watching this